Space exploration has always been a beacon of human curiosity and ambition. It all started in 1957 when the Soviet Union launched Sputnik 1, the first artificial satellite to orbit Earth. This moment marked the beginning of the space age and ignited a fierce competition between nations. Just 4 years later, in 1961, Yuri Gagarin became the first human to journey into outer space, completing an orbit around Earth. Aboard Vostok 1, these early milestones weren't just about technological achievements, they were about pushing the boundaries of what we thought possible. Since then, over 500 people from more than 30 countries have traveled to space, and their experiences have provided invaluable scientific insights into our universe. From understanding cosmic phenomena to developing life-saving technologies like satellite communications and GPS. The impact of space exploration is immeasurable. As we delve deeper into this journey, let's explore how these early steps paved the way for today's ambitious missions to Mars and beyond. Space exploration began in earnest during the Cold War era, when nations raced to demonstrate technological superiority. The Soviet Union took the lead by launching Sputnik 1 on October 4, 1957, marking the first artificial satellite to orbit Earth. This small sphere, about the size of a beach ball and weighing just over 183 pounds, circled our planet every 96 minutes. Sputnik's launch shocked the world and spurred the United States to accelerate its own space program, leading to the creation of NASA in 1958. The space age had begun, igniting an era of rapid technological advancement and fierce competition between superpowers. This early milestone set the stage for future missions to the moon and beyond, paving the way for humanity's continued quest into the cosmos. The space race between the United States and the Soviet Union was one of the most intense competitions of the Cold War era. It began in earnest on October 4, 1957, when the Soviets launched Sputnik 1, the first artificial satellite to orbit Earth. This event shocked America and spurred them into action. Just a year later, in July 1958, NASA was established to lead American efforts in space exploration. The competition heated up even more with the moon as the ultimate prize. On July 20, 1969, the United States achieved a monumental victory when Neil Armstrong and Buzz Aldrin became the first humans to walk on the lunar surface during Apollo 11. This marked a significant milestone in human history and showcased the technological prowess of both nations. The space race not only pushed boundaries in space, but also had profound impacts on technology and international relations back on Earth. As we move forward, it's fascinating to see how these early steps have paved the way for today's advanced space missions and collaborations. The Apollo program stands as one of humanity's greatest achievements in space exploration. Launched by NASA in the late 1960s, its primary goal was to land humans on the moon and return them safely back to Earth. On July 20, 1969, Apollo 11 made history when astronauts Neil Armstrong and Buzz Aldrin became the first humans to set foot on the lunar surface. As Armstrong stepped off the lunar module Eagle, he famously declared, "That's one small step for man, one giant leap for mankind." Over the course of 6 missions, 12 astronauts walked on the moon, collecting samples and conducting experiments that transformed our understanding of Earth's natural satellite. The Apollo program not only marked a significant milestone in space exploration, but also inspired generations to push the boundaries of science and technology. As we continue to explore the cosmos, the legacy of these pioneering missions remains a testament to human ingenuity and perseverance. Next up, let's dive into the challenges faced during these lunar voyages. In 1977, NASA launched 2 Voyager probes on an ambitious mission to explore our solar system and beyond. Voyager 1 and Voyager 2 were equipped with scientific instruments to study planets and their moons as they journeyed through space. After passing by Jupiter and Saturn, Voyager 1 veered northward out of the plane of the solar system, while Voyager 2 continued southward past Uranus and Neptune. Today, both probes are traveling beyond our solar system into interstellar space. Voyager 1 crossed this threshold in 2012, becoming the first human-made object to enter interstellar space. As of now, Voyager 1 is over 15 billion miles from Earth, still sending back data that helps us understand the mysteries of the cosmos. Next up, we'll explore how these probes have transformed our understanding of distant planets and the vastness beyond them. The Hubble Space Telescope has been one of our most valuable tools in understanding the cosmos. Launched into low Earth orbit in 1990, it's captured some of the most detailed images of space ever seen. One of its key achievements is the Hubble Deep Field Image, which revealed thousands of galaxies in a tiny patch of sky that appeared to be empty before. This project alone has revolutionized our understanding of galaxy formation and evolution. Another significant contribution is its role in measuring the expansion rate of the universe by observing distant supernova. These observations have helped us refine the age of the universe to about 13.8 billion years. The Hubble's legacy continues to inspire new generations of astronomers, setting the stage for even more advanced telescopes like the James Webb Space Telescope. As we continue our journey into space exploration, Hubble remains a beacon of discovery and wonder. The James Webb Space Telescope, often hailed as the successor to Hubble, represents a monumental leap in our astronomical capabilities. Launched on December 25, 2021, this next-generation observatory is designed to peer deeper into space than ever before, thanks to its massive gold-coated primary mirror that spans over 6.5 meters in diameter. This size allows it to capture the faint light from some of the first galaxies formed after the Big Bang, potentially dating back nearly 13.5 billion years. Equipped with advanced infrared sensors, the Webb can see through cosmic dust clouds, revealing hidden stellar nurseries and distant exoplanets. Its unprecedented resolution is set to revolutionize our understanding of star formation and galaxy evolution. With a mission life expectancy of at least 5 years, the James Webb Space Telescope promises to deliver groundbreaking discoveries that will redefine astronomy as we know it. As we delve deeper into space exploration, these insights will undoubtedly shape future missions and our broader comprehension of the cosmos. The International Space Station, or ISS, is truly a marvel of human engineering and international cooperation. Orbiting Earth at an altitude of about 408 kilometers, this massive structure has been continuously inhabited since November 2, 2000. It serves as a microgravity laboratory where scientists from around the world conduct experiments in biology, physics, astronomy, meteorology, and other fields. For instance, the station hosts over 37 different research facilities that have supported more than 3,000 investigations from researchers in 108 countries. One groundbreaking experiment involves growing plants in space to understand how they adapt to low-gravity environments, which could be crucial for long-term space missions. The ISS is not just a symbol of what we can achieve together. It's also a beacon of hope and knowledge for the future of humanity beyond Earth. As we continue our journey into the cosmos, the lessons learned here will undoubtedly pave the way. Mars has been a focal point in space exploration for decades. Since the first successful landing of NASA Viking mission back in 1976, we've sent numerous rovers to explore the Martian surface. One of the most famous is Curiosity, which landed on Mars in August 2012 and continues its mission today, analyzing soil samples and searching for signs of past life. Curiosity has driven over 23 kilometers across the planet's surface, sending back incredible images and data. The rover Opportunity operated from 2004 until 2018, far exceeding its original 90-day mission duration. These missions have not only expanded our understanding of Mars, but also paved the way for future endeavors like the upcoming Mars Sample Return mission, which aims to bring Martian soil back to Earth for detailed analysis. As we continue to explore Mars, each discovery brings us closer to unraveling the mysteries of this red planet and potentially uncovering its habitable past. The idea of colonizing Mars has captured our imagination for decades. SpaceX's ambitious plans, led by Elon Musk, aim to send humans to Mars within this decade. With the goal of establishing a self-sustaining city, they envision thousands of people living on the red planet. NASA also envisions human missions to Mars in the 2030s as part of its Artemis program. While the challenges are immense, including protecting astronauts from radiation and ensuring life support systems function, the potential rewards could be enormous. Colonizing Mars could help us understand more about our own planet's history and evolution. It also offers a safeguard for humanity against catastrophic events on Earth. As we continue to develop technologies like advanced propulsion systems and life support habitats, the dream of living on another world inches closer to reality. Next, let's explore some of the incredible technology that will make this journey possible. In recent years, private companies like SpaceX and Blue Origin have transformed space exploration. SpaceX, founded by Elon Musk in 2002, has revolutionized rocket technology by developing reusable rockets that significantly reduce launch costs. For instance, their Falcon 9 rocket can now return to Earth and be reused multiple times, cutting the cost of access to space by a factor of 10. Blue Origin, led by Jeff Bezos, focuses on sustainable space travel with its New Shepard spacecraft designed for suborbital flights. In fact, in July 2021, Blue Origin's first crewed flight carried 6 people to space, including Bezos himself. These companies are not just pushing the boundaries of technology, but also opening new avenues for commercial and scientific endeavors beyond Earth. As we look ahead, these private enterprises will likely play an even more pivotal role in shaping our future among the stars. As we look ahead to the future of space exploration, there are numerous challenges and opportunities on the horizon. One major challenge is the harsh environment of outer space itself, where extreme temperatures, radiation, and microgravity pose significant risks for both human health and technology sustainability. For instance, NASA Mars 2020 mission faced technical difficulties with its sample caching system, highlighting the complexity of operating in such remote conditions. On the other hand, there are exciting opportunities like the potential to discover new resources on celestial bodies. The Moon, for example, contains vast deposits of helium-3, a non-radioactive isotope that could provide clean energy through nuclear fusion reactions. Additionally, private companies like SpaceX are pushing the boundaries with reusable rockets, significantly reducing launch costs and making space travel more accessible. As we continue to explore these frontiers, the next scene will delve into how international collaboration can play a crucial role in overcoming these challenges and realizing our ambitious goals in space exploration. Space tourism is no longer just a dream, it's becoming a reality. Companies like Virgin Galactic and SpaceX are leading the charge to make space accessible to civilians. In 2021, for instance, Jeff Bezos became one of the first billionaires to travel to space aboard Blue Origin's New Shepard rocket, marking a significant milestone in commercial spaceflight. This venture into space tourism is expected to grow exponentially, with estimates suggesting that by 2030, over 100,000 people could be taking suborbital flights each year. The economic impact of this new industry is projected to reach billions of dollars, potentially revolutionizing how we view and interact with the cosmos. As more companies enter this market, we can expect innovations that will make space travel safer, more affordable, and accessible to a wider audience. This opens up a whole new realm of possibilities for scientific research and exploration. Next, let's explore some of the challenges and ethical considerations surrounding space tourism. International cooperation has been a cornerstone in advancing our understanding of space. For instance, the International Space Station, ISS, is a prime example where 15 countries have collaborated to create and maintain this orbiting laboratory. Since its first crewed mission in November 2000, the ISS has hosted over 240 individuals from various nations, conducting thousands of experiments that wouldn't be possible on Earth. This collaboration not only fosters scientific advancements, but also promotes peace and unity among participating countries. Another notable example is the European Space Agency's Rosetta mission, which involved scientists from across Europe working together to land a probe on a comet for the first time in history. These collaborations show how pooling resources and expertise can lead to groundbreaking discoveries. As we look towards future missions to Mars and beyond, international cooperation will only become more crucial. Space exploration has driven some of the most groundbreaking technological advancements in history. For example, the need for reliable communication systems led to the development of satellite technology, which today connects billions around the globe. Another significant innovation is memory foam, originally developed by NASA to improve airplane seat cushioning and now widely used in mattresses and sports equipment. These aren't just random inventions. They've directly improved our daily lives. In fact, according to NASA spin-off database, over 2,000 technologies have been spun off from space research since the 1970s. From water purification systems to heart pumps, these innovations demonstrate how space exploration has a profound impact on Earth. As we continue to push the boundaries of what's possible in space, who knows what other life-changing inventions will come next? Space exploration has given us an incredible vantage point to study our own planet. Satellites orbiting Earth have provided critical data on climate change and environmental shifts. For example, NASA GRACE mission revealed that between 2002 and 2016, the Greenland ice sheet lost about 281 gigatons of ice per year. This kind of information is crucial for understanding how our planet is changing over time. Similarly, satellites like the Landsat series have been monitoring land use changes, deforestation rates, and agricultural impacts since the 1970s. These observations help us track human activities that affect Earth's ecosystems. By looking at our planet from space, we gain a broader perspective on environmental issues and can work towards more sustainable practices here on Earth. Next, we'll explore how space exploration has inspired technological advancements in everyday life. Space exploration has not only pushed the boundaries of science and technology, but also profoundly impacted our culture. The The iconic image of Earthrise from the moon, captured by Apollo 8 astronauts in 1968, shifted our perspective on our planet's place in the cosmos. This photograph is credited with boosting environmental awareness and inspiring movements like Earth Day. Space exploration has also influenced popular culture. From Stanley Kubrick's 2001, A Space Odyssey, to Star Trek's vision of a unified humanity exploring the stars. These cultural touchstones have not only entertained, but also inspired generations of scientists and engineers. The allure of space even extends to fashion. NASA iconic spacesuits have been reimagined by designers like Dries Van Noten, blending functionality with avant-garde style. As we continue to explore beyond our planet, the cultural impact will undoubtedly evolve, shaping new narratives and inspiring future explorers. Space exploration has always been a powerful catalyst for inspiring future generations to pursue STEM fields. Did you know that NASA education programs have reached over 10 million students and educators? These initiatives not only spark curiosity, but also provide hands-on experiences that can ignite lifelong passions in science, technology, engineering, and math. For example, the Mars Student Imaging Project allows middle school students to actually control a camera on the Mars Odyssey spacecraft, giving them real-world experience in space research. Programs like these are crucial because they show young people what's possible when you combine creativity with scientific inquiry. By engaging kids early and often, we can ensure that the next generation of scientists and engineers is ready to push the boundaries of human knowledge even further. As we look ahead, it's clear that fostering this passion will be essential for our continued exploration of the cosmos. Space exploration has always been a global endeavor. Over 50 countries have participated in space activities, from launching satellites to conducting joint missions like the International Space Station, which has involved contributions from 50 nations. This collaboration showcases how space unites us beyond borders and political differences. For instance, NASA Mars Perseverance rover mission includes instruments from Spain, Norway, and France. Looking ahead, this global cooperation could lead to groundbreaking discoveries, such as mining resources on the moon or establishing human settlements on Mars. The future of space exploration holds immense potential for international collaboration, driving technological advancements and fostering peace through shared goals in the cosmos. As we continue to push the boundaries of what's possible, the stars will remain a beacon, guiding our collective journey forward. As we look forward to the stars, it's clear that space exploration is far from over. In fact, NASA plans to return astronauts to the moon by 2024 as part of the Artemis program, setting the stage for future missions to Mars and beyond. The private sector is also playing a significant role. SpaceX has already launched over 150 Starlink satellites into orbit with the goal of providing global internet coverage. This ongoing journey holds endless possibilities, from mining asteroids for resources that could sustain life on Earth to discovering new planets where humanity might one day live. As we continue to push the boundaries of what's possible, each launch brings us closer to unlocking the mysteries of our universe. So as we close this window into the cosmos, remember that the stars are just the beginning, and the future is full of infinite possibilities waiting for us to explore them.